The cosmic ballet our planet performs would become far more complex, more dynamic, and ultimately, more dangerous. The arrival of Selene would rewrite the laws of our world. It would change everything we take for granted, from the brightness of our nights to the height of our seas. The sky would never look the same again. This new celestial body would not simply be a curiosity. Its presence would introduce a new gravitational force into the Earth-Moon system. The delicate balance that has existed for eons would be disturbed. The predictable, gentle rhythm of our world would be replaced by something far more volatile. Selene's orbit would interact with Luna's, pulling and tugging at our familiar companion. The night sky would become a stage for a dramatic and unpredictable play. The familiar comfort of our one moon would be gone, replaced by the awe and uncertainty of two. Our relationship with the night would be forever transformed. Imagine stepping outside on a clear night in this new world. The sky would be a spectacle of unparalleled beauty. Luna, large and brilliant, would still command the darkness, its familiar gray plains and craters on full display. But it would be joined by Selene, a smaller, sharper point of light, perhaps appearing half the size of Luna, but shining with a fierce intensity. Sometimes they would appear together, two silver discs hanging in the velvet blackness. At other times, one would rise as the other sets, ensuring the night is never truly dark. The world would be bathed in a constant, ethereal twilight. This perpetual moonlight would change the very nature of life on Earth. Nocturnal animals, accustomed to the deep dark, would need to adapt to a world that is always partially illuminated. The behavior of predators and prey would shift in this new, brighter environment. For humanity, the change would be profound. Our cities, already glowing with artificial light, would seem even brighter. But in the wild, far from the glare of civilization, the landscape would be painted in shades of silver and gray. The romance and mystery of the dark night would be replaced by a different kind of wonder, a sky dominated by two celestial queens. The two moons would rarely look the same. As they moved in their separate orbits, their phases would fall out of sync. You might see a full Luna alongside a crescent Selene. Or Selene could be a brilliant full disk, while Luna is a barely visible new moon. Sometimes, one moon would pass in front of the other, creating a stunning double eclipse. The smaller Selene would appear to bite a chunk out of the larger Luna before passing on. These celestial events would become the new folklore, the new markers of time for cultures all around the world. The sky would be a constantly changing canvas of light and shadow. Our connection to the cosmos would feel more immediate, more dynamic. Astronomy would become a subject of even greater fascination. People would track the complex paths of the two moons, predicting their conjunctions and eclipses with excitement. The night would no longer be a simple backdrop for the stars. It would be a three-dimensional stage where two majestic worlds performed a mesmerizing dance. The sight of two moons would remind us that our solar system is not a static museum piece, but a living, breathing system of immense power and beauty, constantly in motion. The beauty of the twin moons in the sky would conceal a powerful and disruptive force. Here on Earth, the most dramatic effect would be on our oceans. Our single moon, Luna, is the primary driver of the tides. Its gravity pulls on Earth's water, creating a bulge that results in high and low tides. It's a predictable, twice-daily rhythm that has governed coastal life for millennia. But with the addition of Selene, this gentle rhythm would be transformed into a violent, chaotic surge. The combined gravitational pull of two moons would be immense, creating tides unlike anything our world has ever known. When the two moons align in the sky, either on the same side or on opposite sides of the Earth, their gravitational forces would combine. This event, known as a syzygy, would create super tides. High tides would become monstrous, surging meters higher than anything we experience today. Coastal areas would be inundated with terrifying regularity. Low tides would be equally extreme, exposing vast tracts of the seabed that are normally hidden beneath the waves. The intertidal zone, that rich ecosystem between high and low water, would be stretched to its breaking point, threatening the countless species that depend on it for survival. Conversely, when the moons are at right angles to each other in the sky, their gravitational pulls would partially cancel each other out. This would lead to unusually weak tides, known as neap tides. The difference between high and low tide would be minimal. This constant fluctuation between extreme super tides and weak neap tides would make coastal living incredibly hazardous. Predicting the sea would become a matter of life and death. The familiar tide charts used by sailors and fishers for centuries would become obsolete, replaced by complex calculations tracking the positions of two celestial bodies. This tidal chaos would not just affect the water. The immense gravitational forces would also pull on Earth's solid crust. This phenomenon, known as Earth tides, happens now but is barely perceptible. With two moons, the crust would be stretched and compressed far more significantly. This could lead to an increase in geological activity. We might see more frequent earthquakes and volcanic eruptions as the planet's crust groans under the strain of the relentless gravitational tug-of-war. The beautiful dance in the sky would have a violent, earth-shaking counterpart right beneath our feet. The Earth-Luna-Selene system would be fundamentally unstable. In our solar system, objects in orbit exist in a delicate gravitational balance. But, introducing a third major body into the Earth-Moon system creates a classic physics problem, the so-called three-body problem. There is no simple, long-term solution for it. The orbits of the two moons would constantly influence each other. They would be locked in a complex gravitational waltz, a dance where a single misstep could lead to catastrophe. Their paths around the Earth would not be the clean, predictable ellipses we imagine. They would wobble and shift over time. Over decades and centuries, the mutual gravitational attraction between Luna and Selene would cause their orbits to change. One moon might be pushed into a higher, slower orbit, while the other is nudged into a lower, faster one. Their orbital paths could become more eccentric or elongated, bringing them closer to Earth at some points and flinging them further away at others. This orbital dance would be a source of constant scientific study and, honestly, public anxiety. Astronomers would watch with bated breath, calculating and recalculating the future of this fragile system. The moon's dance is not a gentle one. It is a battle for gravitational dominance. The greatest danger would be a phenomenon known as orbital resonance. This could happen if the orbital period of one moon became a simple fraction of the others. For example, if Selene completed exactly 2 orbits for every 1 orbit of Luna. In this scenario, the gravitational tugs between them would happen at the same point in their orbits every time. This regular, repeated pulling would amplify over time, destabilizing their paths dramatically. It's like pushing a child on a swing. A gentle push at the right moment sends them higher and higher. In space, this could push one moon out of the system entirely, or worse, set them on a collision course. Living on Earth would mean living with the knowledge that our celestial neighborhood is unstable. The 2 beautiful moons in our sky would also be a constant reminder of our planet's vulnerability. They would represent a cosmic ticking clock. While the timescale for this instability could be thousands or even millions of years, the outcome would feel inevitable. Humanity would be a spectator to a cosmic drama playing out over our heads, a drama whose final act could reshape our world forever. The gravitational waltz would be beautiful, but it would be a dance on the edge of a precipice. After millennia of a precarious dance, the inevitable happens. The orbits decay. The gravitational waltz falters. Luna and Selene are drawn onto a collision course. In the final weeks, the two moons would dominate the night sky, appearing larger and larger as they spiral towards each other. They would fill the heavens, their surfaces visible in terrifying detail. There would be no escaping the spectacle. Every human on Earth would become an astronomer, watching the slow, silent, and horrifying approach. Then, in a moment of unimaginable cosmic violence, they collide. The impact would be silent in the vacuum of space, but its visual effect would be breathtaking. A brilliant flash of light would outshine the sun, visible even in broad daylight. The two worlds would shatter. A vast cloud of incandescent rock and dust would erupt outwards from the point of impact. For a moment, where two moons once orbited, there would be a new, expanding star of molten debris. This debris would not be contained. It would spread out, forming a vast, flat ring system around the Earth, similar to the rings of Saturn, but brighter, hotter, and far more chaotic. From the surface of Earth, the sky would transform. The familiar faces of the moons would be gone forever. In their place, a brilliant, glowing arch would stretch from horizon to horizon. This would be the new ring of debris, a celestial monument to the cataclysm. In the days and weeks following the collision, this ring would begin to cool and coalesce. Gravity would immediately go to work on the rubble. The larger fragments would start pulling in the smaller ones. A process of accretion would begin, the slow and steady clumping together of material to form a new single body. The initial ring would be unstable. The fragments would grind against each other, creating a constant shower of smaller particles. The sky would be a place of constant, slow-motion change. The bright arch would gradually resolve into clumps and clusters, the birth pains of a new moon. Watching this process would be a humbling experience for humanity. We would be witnessing in real time the same fundamental process that formed the planets and moons of our solar system billions of years ago. The destructive end of two worlds would become the creative beginning of one. While the collision itself happens far above, its consequences would be felt immediately and catastrophically on Earth's surface. The moment the two moons shatter, their combined gravitational influence on our oceans disappears and then rapidly changes. The carefully balanced tidal bulges, which were already extreme, would be thrown into utter chaos. The water of the oceans, no longer held in a predictable pattern, would slosh around the planet like water in a violently shaken bowl. This would trigger a series of unimaginable tsunamis, not from earthquakes, but from the gravitational release itself. These are not waves, but the entire ocean rising at once. Gigantic surges of water, hundreds of meters high, would scour the coastlines of every continent. Every major coastal city in the world, New York, Tokyo, London, Sydney, would be submerged. The devastation would be absolute. The familiar maps of our world would be redrawn in a matter of hours. Billions of people living near the coast would be forced to flee inland in the greatest migration in human history. The infrastructure of our global civilization, so heavily concentrated along the coasts, would be wiped out. The new ring of debris would exert its own gravitational pull. As the larger fragments begin to clump together, they would create localized and unpredictable tidal forces. The oceans would not settle. They would be pulled and pushed by the shifting masses in the sky, creating rogue tides and currents that would make coastal regions uninhabitable for generations. The world's climate would also be thrown into disarray. The massive release of energy and the change in ocean currents would trigger extreme weather events across the globe, from hyper-hurricanes to prolonged droughts. Humanity would be forced to retreat to higher ground, to the mountains and the continental interiors. New cities would have to be built, and a new way of life established. The old world, the world of beaches and ports and seaside towns, would be lost beneath the waves, a modern Atlantis. Survival would depend on cooperation and ingenuity on a scale never before seen. We would become a species of mountaineers and highlanders, looking down upon the turbulent, angry oceans that had claimed our former homes, all while a new world was being forged in the sky above us. The sky after the collision would be both beautiful and terrifying. The glowing ring of debris would dominate the heavens, a constant reminder of the lost moons. But this ring would also be a source of new peril. The collision would have sent countless smaller fragments, from the size of pebbles to the size of mountains, into chaotic orbits. Many of these would be drawn in by Earth's gravity. For years, perhaps even centuries, the planet would be pelted by relentless meteor showers. The night sky would be permanently streaked with shooting stars, the fiery death throes of the former moons. Most of these meteors would be small, burning up harmlessly in the atmosphere as spectacular light shows. But inevitably, larger pieces would survive the journey. Impacts would become a regular occurrence. A rock the size of a car could obliterate a city block. A larger one could create a crater miles wide, triggering regional devastation. Humanity would have to develop advanced detection and deflection systems to protect itself from this celestial bombardment. Life would continue under the constant, low-level threat from above. The heavens would no longer be a place of serene beauty, but a cosmic shooting gallery. Over thousands of years, the chaos would subside. In the sky, the process of accretion would complete its work. The countless fragments in the ring would have been swept up, pulled together by gravity to form a single new moon. This new moon would be a mosaic of its parents, a sphere of fused rock and dust, bearing the scars of its violent birth. Its orbit would eventually stabilize, and it would once again exert a steady, predictable pull on the Earth. The extreme tides would calm, and the oceans would retreat, revealing the drowned coastlines of a lost era. Life on Earth would have been irrevocably changed, but it would endure. Humanity, having survived the Great Deluge and the years of fire from the sky, would emerge resilient and transformed. We would look up at the new moon, a familiar yet alien sight, and see a symbol of renewal. It would be a testament to the universe's endless cycle of destruction and creation. We would have lost two worlds but gained a new one, and in the process gained a deeper understanding of our own fragility and our profound capacity for hope. The long night would be over, and a new dawn would have begun.